Everywhere in every aspect of our everyday life, we encounter forces in motion. The laws concerning these, the famed Isaac Newton's three laws. For those who don't know who Isaac Newton is, he was an English mathematician, physicist, and astronomer during the late 17th century and early 18th century. Understanding these three laws of motion has helped us in especially space exploration, inventions, and other aspects of life. Before Newton's time, many people thought objects slowed down because they had the natural tendency to slow down. But they did not take into account of the many forces of Earth like friction, gravity, air resistance, and other forces that cause changes to velocity. In this video, we will demonstrate and explain Newton's three laws: the law of inertia, the law of force, and the law of the conservation of momentum.
Inertia is a term that means an object will have the tendency to keep on doing what it is doing. An object with more mass has more inertia than an object with a lesser mass. Newton's first law, also known as the law of inertia, refers to the following statement. An object at rest stays at rest, and an object in motion stays in motion with the same speed and direction unless acted upon by an unbalanced force. In other words, suppose there is a ball sitting at rest on the floor. This ball will continue to sit still and will have no tendency to move. That is, until an outside force acts upon it. This outside force can be a simple kick. After this kick, the ball will continue to roll until it is acted upon by an outside force. Normally on Earth, a ball will slowly stop rolling. This is because there are a multitude of forces acting upon the ball while it is rolling. The main force that causes the ball to stop rolling is friction. Friction is a force between the ball and the ground. Another demonstration of Newton's first law involves a glass, a stiff note card, and a coin. Setting the card on top of the open glass, we put the coin on top of the card, and then, making a quick flick to the card starts flying away. The coin that was sitting on top wants to remain sitting on top of the card, and once there is no card to hold the coin up against gravity, gravity takes over, pulling the coin straight down. This shows how inertia is seen every day in our lives, through the coin's tendency to stay in the same place.
Newton's second law is considered one of the most important laws in physics. It is really important that you master this law. It states that net force equals mass times acceleration. In other words, the acceleration of an object produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force, and inversely proportional to the mass of the object. An important thing to note is that net force is the vector sum of all the forces acting on an object. Also, a unit of force is equal to a unit of mass times a unit of acceleration. By substituting the metric units for force, mass, and acceleration, the unit of equivalence is 1 Newton equals 1 kg times 1 meter divided by second square. To demonstrate this, we are going to kick a basketball. Since force and acceleration have a direct relationship, if we kick the ball harder, it will fly away faster, which means a higher acceleration. If we kick the ball softer, it won't go as fast due to the force being less. However, if we were to kick a heavier ball, a ball with more inertia, and kick it with the same force, the acceleration of the ball would be smaller because force is inversely proportional to the mass. To require a heavier ball to roll or go at the same acceleration as a lighter ball, it requires more force.
Newton's third law is probably the most famous. It states that every action has an equal and opposite reaction. It is also known as the law of conservation of momentum. This can be demonstrated by a balloon flying through the air. The air comes out of the balloon as it is released and pushes backwards. The equal and opposite reaction of this push causes the balloon to fly forwards. Now you may be thinking, wait, if every action has an opposite reaction, then how could anything move? This is because of momentum, which can be demonstrated by two colliding objects. As these two balls collide, they exert equal forces on one another. However, since one ball is much larger and has more mass, their accelerations will be unequal. The larger ball will lose momentum and roll away slower. This type of collision is called an elastic collision. This means that the kinetic energy is conserved. In an inelastic collision, objects would lose kinetic energy due to friction. They could also stick together and have a common final velocity, which is referred to as perfectly inelastic.